Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hi, Anna. Thank you so much for that warm introduction. Happy to be here. My name is Julia. I work at Microsoft as a cloud developer advocate, and I'm really excited to be here with all of you today for the launch of the JavaScript AI Buildathon. And if this is the first time you're hearing about it, don't worry, I'll give a pretty good introduction as to what this is and what we'll basically be doing for the next couple of days. So for today, before we even get started, we have quite a lot to unpack. I'd really love to know who we have on the stream. I know that we have so many people joining from different parts of the world. So if you could please just drop a hi on the chat and let us know where you're joining in from. You can mention your country, mention your state, and we'll basically just see the global representation that we have on today's live stream. So I see we have several people joining from different parts of the world. We have Bernard joining from Kenya, that's Kirinyaga University. We have Mike from South Carolina. We have Anthony from Kirinyaga. Welcome to the stream. Welcome, Ravid from USA. And I see we have so many people joining in. Super excited to have you. We have so much to cover. So keep the introductions coming in on the chat. We'll basically keep recognizing all of you that have joined us. So today we're going to do basically two key things. I'm going to introduce the Buildathon, give an overview of the program, and then I have amazing speakers lined up today to talk to us about everything regarding building AI solutions locally. So you might be asking yourself, what is the JavaScript AI Buildathon? So this is basically a virtual skilling series that highlights modern AI patterns using JavaScript. And you might also wonder, why are we doing this? An observation that I've made, you can let me know on the chat if you've also made a similar observation, is that most AI learning resources, whether tutorials, code examples, blogs, they mostly assume that you're working in Python. But the reality is that today, JavaScript powers applications that are used by billions and billions of developers and people all around the world. So basically, with this Buildathon, we are hoping to build content for the vast communities we have with JavaScript developers who are eager to explore and experiment what's possible with AI using their tech stack of choice. And so to address this, we have the Buildathon, which basically provides a curated hands-on learning experience that is tailored for JavaScript developers to explore the full suite of capabilities with AI. So the program itself will run from today, March 2nd, being the kickoff date, and will run all the way to March 31st. We'll have different learning opportunities and mediums, so we won't just be doing these live streams. Live streams are just a part of what we'll be doing, but we'll also talk about the other different ways that you can engage and participate in the program. The Buildathon itself, as you can see on the screen, has two key phases. Phase one is the learn and upskill phase, where you basically go through a bunch of resources and training sessions to get up to speed with the latest and the greatest AI technologies for JavaScript developers. This will include live streams like the one that we'll have today. This will also have expert AMA sessions. So immediately after this live stream, we will hop on to Discord to have a closer discussion with our speakers. And then we're also going to have self-paced hands-on quests. I'll be showing this to you in a few minutes. And then this will also come with some guided projects. So we have some end-to-end implementations of different AI systems across different scenarios. And you'll basically have a chance to go through these end-to-end implementations and get to understand how the different pieces connect to each other. So for the schedule, as you can see on the screen, we'll be having 3 sessions a week. That is for this week and next week. We'll start with Today Local AI. On Wednesday, we'll be back to cover the end-to-end model development experience on Foundry. And then on Friday, we'll have a session covering advanced RAG concepts. Next week on Monday, we'll start off with AI Toolkit, an incredible tool that will allow you to design and build agents locally. And then on Wednesday next week, we'll basically look at how we can scale them on Microsoft Foundry. And then on Friday, we are going to announce the hack. The hack is phase 2 of the Buildathon, where you basically now apply what you'll have learned throughout and participate in a hackathon, and you basically just build working and meaningful AI solutions. All right, so we are available on different spaces. So you will be able to access different conversations on GitHub. So for example, we do have specific discussions for each and every topic that we'll be covering, from Foundry Local, agentic design, RAG. So basically just hop in on the discussions, and a link to this will be dropped on the chat. And then you can basically drop in any questions you have, any comments that you have, any ideas that you probably have around the different topics that we have. That's the first platform where you can engage with different experts and community members. But we also have a space, a dedicated space on the Foundry community that's on Discord. So for you to get started, basically just, again, a link will be shared on the chat. So with this, you can go on the hack and events sections, and then you'll find the JS AI Buildathon channel. And this is where you can connect with the larger community. You can have conversations, you can find collaborators for your projects, and we have an amazing team of moderators ready to answer any questions you might have throughout the program duration. So with that, I'm going to basically introduce our speakers for today. We have Lee and Sam, who will come on stage and they will talk to us about local AI development. So as you're thinking about the projects that you'll be building, you might want to have local or offline AI capabilities. So how do you think about building the solutions? Where do you start? What are the tools that you have access to? So welcome, Lee. Welcome, Sam. And if you have any questions, please drop them on the chat. We'll keep addressing them as we continue. Over to you, Lee.
Huge thanks, Julia. So welcome everyone to the Buildathon. So as Julia said, this is our first session. Today we're going to be focusing very much on building on local AI. So I've got some great sessions planned for you today, and I've got Sam Kemp with me, who is one of the program managers. So the program manager for the JavaScript SDK. So Sam, do you want to quickly introduce yourself?
Yeah, thanks, Lee. Yeah, so I'm Sam Kemp. Yeah, I work in the engineering division in Core AI at Microsoft, and yeah, we build the Foundry Local SDK and core components as well that does all the inferencing. So using things like the Onyx runtime.
So Sam, I'm really excited by the opportunity of Foundry Local. I was at the AI tour in London last week, and Satya, was keynoting the presentations, and he actually, announced Foundry Local as being now available in Foundry Local. So the whole opportunity of being localized to Azure, the opportunity of running models locally within the edge. So, what do you see as like the big opportunities of edge-based computing and Foundry running in the private networks of organizations?
Yeah, so I think like there's a few sort of like key motivations that we find from customers and users of Foundry Local. So one of those is just like disconnected, like if you're on a mobile app, for example, and you get in a spotty Wi-Fi, that you still want to access the AI on there, right? You don't want it to be just like can't connect, right? Like you might get with some personal assistance if you're in sort of the in the sort of backwaters and so forth. So that's one reason. And then another is like privacy as well. So there's just certain scenarios where people want to keep that on the device, whether it's for sort of healthcare scenarios. That comes up quite a bit. And also reducing cogs as well of your application. So not every single prompt in your application would need to go off and run in a large language model in the cloud. Like some of that traffic can go to the local device, and you can get a cogs saving on that.
Yeah, so again, lots of people may not have heard of Foundry Local. It's very new. It's still in preview at the moment. So if you have heard of things like Ollama or LM Studio, Foundry Local is really the Microsoft equivalent solution to running localized models. Now, it has a number of different opportunities which are very specialized in terms of private registry, secure models, and trusted models. So, Sam, do you want to give us a bit of an overview and an introduction to what Foundry Local is? I know you've got some slides.
Yeah, sure. Let me go to the slides now. So let me just put this in the old presenter mode. Just to sort of set this up, so we have sort of like Microsoft Foundry, which is out in the cloud, and then there's like Azure Local, which is kind of on what you might call like the heavy edge, right? So it's on-premise, air-gapped clouds, and then you have like Foundry Local, which is sort of the on-device. And you mentioned Ollama, and so like typically when you want to build an application that leverages local inference, you sort of have your application code up here, which has got like the OpenAI SDK and the Ollama SDK, but that needs to call into a REST service here, right, that runs over HTTP. Now, this is all fine for like dev test, right? This is all pretty good. But what happens when you want to ship the application? Well, what that means is that you have to sort of ship your app, and you also have to have a mechanism to ship Ollama as well, or you have to ask your users, your end users, to go and download Ollama, right? So there's this external dependency, and this makes things quite tricky, right? So what we've sort of learned from doing this sort of like internally and from customers is that folks really want like the app to be self-contained, like not having those external dependencies. And the other thing is that like size matters. Like the smaller your app package, the better, right? There is often constraints in app stores to like 150 megabytes. So if you start putting in big external dependencies, like you don't get into those limits, right? And then also people like want this sort of familiar and simple like cross-platform from APIs, and sort of going beyond chat, like more into audio and tool calling. And so we've worked in order to do this, and just talking about the models as well. Like one of the things that we do in Foundry Local is our models are coming from Foundry, Microsoft Foundry catalog. And we do a lot of model optimization. We do so not just like simple quantization where we'll take the whole weights. We'll actually do things like AWQ, quantization, caret, these sort of sophisticated methods, so that you get both performance but without degrading quality. And so we really do like lean into that quite heavily to make sure that we're getting high quality outputs. And so where like Foundry Local like differs to that approach from sort of Ollama and LLM Studio is you can have a completely self-contained application. So all the components you'll go and get, if you work in C#, it's a NuGet package, JavaScript that we're going to be talking about today, like it's an NPM. You pull that in, and that is it. All your dependencies are done, right? Like you don't need to get your end users to install anything additionally. You can just ship your application, and that works by having, like I mentioned at the beginning, like we work on the Onyx runtime, which is a super lightweight and an efficient inferencing engine, and we built this like DLL, what we call Foundry Local Core. And this like handles like native calls. And if you want to, you can like spin up a optional REST server if you want to use like the OpenAI SDK and do things over REST. You can do that, and it's still self-contained in your application. But you'll see in a second, like our native calls, if you want to come down here, they accept the OpenAI request response format, which means that you can kind of switch between things like pretty seamlessly. So if we just kind of look at the timeline of Foundry Local, so back at Build 2025, that's when we did an initial release. In August, we sim shipped the OpenAI GPT OSS model. And then in September, we added support for WinML, which allows, if you're on Windows devices and your end users are on Windows devices, they might be using like an MPU for that, or sort of very specific hardware accelerators. We've added support for that, so we just natively will use the MPU. And then Ignite, so just at the tail end of last year, we redesigned the SDK to be this self-contained, which we're showing you today. We added audio capabilities, and we announced like Foundry Local on Android and Kubernetes.
So Sam, just to ask a couple of questions, we've got some great questions coming into the chat around this. So in terms of where we are today with Foundry Local, we support Windows natively as an install, so it's a winget package. We support Mac OS. Is there like an option for Linux and containers? I saw you had that in the slide. So is that also an option for people?
Yes, so that is. So on our latest and greatest SDK, you can run that on Linux as well. Yeah.
And in terms of OS, in terms of language support, there's SDKs for Python, JavaScript, .NET. Any additional ones coming as well?
Yeah, so we've got .NET, Python, JavaScript. We're also looking at adding C++ as well in the like very near future.
Yeah, and Foundry Local has a dedicated SDK and a set of APIs as well, doesn't it? Which also map to the Microsoft Foundry API stack, so you can work on a hybrid. So you could do local model inferencing, cloud model inferencing from the same code base.
Exactly. So, and that's definitely by design. So again, coming back to these motivations, right? If you want to be able to access, you might want to default to the cloud, but then just come back and your application uses the local inference if in a disconnected scenario. So you don't want to have to like rewrite or do a bunch of like re-engineering of work to be like, oh, now I'm using the cloud and now I'm using local. It's the same API so that you can seamlessly switch between the two.
Yeah, so a great question from Ken was around, the Mac OS support. Yes, it's fully supported. It's fully native. It's available on Chocolatey and Brew. It's there, isn't it?
And also, just to add to that, like a lot of questions we get around Mac OS is like, oh, is this using like Metal, which is like the super fast, efficient runtime on Mac OS? And we do. So the way that we do that, just to give a bit of technical detail, is we optimize the model for web GPU on the Onyx runtime. And in the Onyx runtime, it uses a Dawn, which is a shader language, to then map that into Metal. So when you use Foundry Local on Mac OS, it is using Metal, the Metal framework of Mac OS, which is the sort of very efficient runtime on Mac OS.
Yeah, and just to add on the Windows side, if you're running a Windows AI PC, so you can either have an Intel or a Qualcomm device, all the models available in Microsoft Foundry have been optimized for that device. So when you install the CLI for Foundry Local and you do Foundry model list, it will list specifically to your device the models which are available and the quantization methods that have been utilized. So you'll see, like, if you have a GPU on the device, you'll see GPU CUDA, GPU if it's an AMD device, or if it's an Intel device, you'll see the Intel Vino models, Open Vino models, and if it's a QNN Qualcomm device, you'll see the the QNN optimized model. So again, when you run Foundry Local on the device, the model availability is specific to that individual device based on the hardware on the device. And, you know, the model selection as well is when you choose a model, it will choose the most optimized model for that device as well. So Sam, can you talk about a bit about, you know, how does Foundry Local do that? You know, it's got all these models there.
Yeah, so the way it does that is, so we use under the covers on Windows devices, there is a piece in the architecture called Windows Machine Learning, or WinML, and that handles these execution providers, right? So it will handle, if you have like a AMD device, it will handle getting the drivers and all the binaries that are required to run the model. It automatically handles pulling that down onto the device and running it if it's not there. And it handles all the versioning as well of the runtime. So if the model has a specific version that it needs to run on of that, like hardware provider, it will make sure it has all the right drivers there for that.
So Mutter Killen's asked a great question about, you know, does Foundry Local support the latest models like Qwen 3.5? So tell us a bit about like the models that are available in Foundry today and the models that are sort of going to come. Well, you don't have to tell us what's definitely coming, but the type of models that are coming to Foundry Local.
Yeah. So we support like Qwen models, and just coming back to like I spoke about before, like around the model quality that we do. So we have very specific requirements within Microsoft about when we release models that they have to be of a certain quality, because we're taking the model and then we're doing this quantization and we're doing all this optimization. We have to sort of prove as part of our responsible AI efforts that we haven't fundamentally changed that model or the quality, and it has to stay within a certain boundary. So we don't have like every single model curated in our catalog, because it could be that we just haven't been able to get it to the quality that's required to meet that standard. But there are things that you can do. So we have a tool called Olive, which is sort of for Onyx Go Live. And Olive will take any model, for example, like Llama model, and it will convert that so that we can run it in Foundry Local. And I can pop this in the chat in a bit, like docs on how you would do that. So if you see a model that is not available, like probably within, depending on your download speed, but probably within like 3 minutes, you can convert that into something that would run on Foundry Local.
Yeah, and again, I'll put the link in for Microsoft Olive. There's also another great site called Olive Recipes. And again, Olive is open source, so it's available on GitHub. And the Olive Recipes is literally a site where you can go and see. So the specifics of models is every single model typically has a different architecture. So Sam, do you want to talk about like, you know, how Olive takes a model architecture and then builds the new model inference?
So one of the things that we've done with Olive is that it's pattern recognition. So one of the things that fundamentally we're using Onyx underneath the covers, right? So what Onyx does is it has a graph. So it takes the neural network graph that you'll see in PyTorch and it converts it into an Onyx format. And what it will do is it might split up certain nodes of that neural network graph into smaller, what we call kernels, so it can run efficiently. And then we have these optimizations on that will go and run. So what Olive does is it snapshots the neural network graph, and then it goes, well, I know how to optimize a bunch of these Onyx kernels already that I see in that graph, and it goes and it does those optimizations. So you could give it like a completely new architecture, and it will still have this memory, right, of how to go and optimize certain elements of that graph. So that's kind of how it works.
Excellent. So great questions there, and thanks for just stopping and pausing a minute, Sam, to answer those. So can you give us a bit more information around Foundry Local then?
Yeah, so just sort of just coming back to the slides, so just to give a sort of flavor for how this works in like JavaScript. Like you can see that here in like this is just like within a few lines. So you do an npm install, right, for the Foundry Local SDK. And then you create a Foundry Local manager. So this, you'll give it like an app name, what kind of logging you want. If you want it to have this optional web server running, you can put that in there with like the URL that you want for that. In this case, it's not going to have any web server running. This is just going to be fully native. And then you can just say, like, go get this model, right? So you say, like, I want this Gwen 2.5. It all goes and downloads it, loads that into memory, and then you can see that you can get a chat client. And this chat client will accept in the, like I mentioned before, the OpenAI request response format. So if you wanted to switch between local and cloud, like you haven't got to go and change like the contracts between those. You fire in the same input between those two things. And then you can like unload the model. And so you can sort of see here, like within like just a few lines of code, you can get something running fully on device. And this, like I say, would be self-contained. So you could ship your application here and give it to somebody else, and this will run, right? They haven't got to go and install any external dependencies for your application.
Yeah, and that's a really neat point that, you know, so you would ship your application, so you bundle your application up, somebody would install it, so they'd run the npm install, it would do the Foundry Local installation, etc. Because the alias of the model is being called, so in the code you can see the construct model, and then it's looking at manager.model get model, and what that is just literally the alias of the model you acquire. So if you wanted to change this from Quen to Phi, all that you would do in the code is replace the model alias with the most appropriate model. And again, hopefully, definitely you all are doing evaluations and benchmarks on the models before you try to build your applications to ensure you get the most effective model for your application. Again, you might be staying with the GPT family of models. So this GPT OSS is available in Foundry Local, or you might be running Quen models or Mistral models, etc. So, you know, this is one of the great opportunities of the portability of using Foundry Local. So today, Sam, how many models do we have available?
I can't remember. It's about, I want to say it's like 30 off the top of my head. I feel like if I say 30, I don't feel like I'm going to be like too far out from.
It's a new model, new day.
new model, new day, yeah. And I think like the other thing to point out is on this alias, like if here I'm running on like a Mac device. So when I put this alias in, let's say I get this application, this is going to go and grab for me like that web GPU, what we call variant of the model, because that's the most optimized for Mac. It will do that automatically. On your device, Lee, I don't know what you're running, but let's just say you've got like a Copilot.
I've got a CUDA box at the moment on this one. So
okay, so you've got a CUDA box. Like, what this will do is it will go and it will pull down the CUDA version and run it on CUDA for you automatically out of the box, right? So when you ship your application, it means that your users that are out there are going to get like the best experience for the hardware that they have, right? So if they're lucky enough, like Lee, to have like a CUDA sat there, like an A100 sat underneath their desk.
No, I haven't.
Then they're going to get that sort of performance, right? And you can tweak that, right? So you can, like, we basically will pull what we believe to be the most performant model for the end user device, but you have complete control as well. So you might say, actually, I always want this to run on like the CPU, and you can kind of totally do that yourself, or you can go and create your own logic around which variant gets installed. Like it's completely kind of configurable to you as the application developer.
And just to come back to the question of, is Quen 3.5 available on Foundry Local? Today it's not available. It's potentially coming very soon or in the future, but you can use models from Hugging Face or external models or fine-tuned specific models, because again, Foundry Local has been built so industry can build clusters of GPU compute and install their fine-tuned private model in Azure Arc as a localized environment for Foundry. So Sam, do you want to I don't know if you've got a slide on this, or I might be preempting your slides, but can you talk to us about like bringing third-party models to Foundry?
Yeah, so unfortunately I don't have a slide on it, but I can talk through it. So as I mentioned before, you install this tool called Olive. And what you'll do is it's like a command line interface. Like those are very, very popular these days, right? So what you do is like you do Olive optimize, and then you give the Hugging Face a model ID. So it'd be like, in this case, like Quen, was it 3.5? You plug that into the command line, it will go and it will just optimize that model for you and put it into the right format so that you can run it in Foundry Local. So yeah, if we don't have those models available, it's like I say, it's yeah, 5 minutes of work and you can get something something running.
And I can show an example of a notebook, and I've just put the link in the chat for a notebook set of examples, which are in, these examples are in Python, but it's a great overview of how to get started with Foundry Local and do the Olive recipes and Olive optimization of models. So again, lots of organizations do heavily invest in private, fine tuning of models, and they want those models to be completely private. And again, that's a great opportunity. Sam, do you want to talk a bit about, where we are in terms of like, so I'm not sure how many of the viewers have got the new Windows AI PC devices. I'm lucky enough to have one. But what's the opportunity there of Foundry Local plus Windows ML and the Windows AI API sets?
Yeah, so with Windows, you really get these enhanced bits around the accelerators, right? That are on the Windows device. So we will handle like all the drivers, right, that are required for that. So they get packaged up into this what we call an execution provider bundle. So that will include the drivers, any of the Onyx components. We handle the life cycle of that as well. So we'll go and, if it's not already on the box, those drivers will actually automatically go and pull it down and install it on the box. And as an application developer, we have an API to that. So you can make it clear to your end users, hey, we're like installing the bits so that we can run this model, like that gets shown there. And it also handles all the updates as well for that. So like it means that we can make sure that the model runs on that specific version that's on the box. That gets handled.
Yeah, and again, from like a user's perspective, once you've got Foundry installed, Foundry Local installed, if you do Foundry model list, you'll see it say EP providers, so execution providers. And what it's doing, it's indexing what resources your machine has, then looking at the available catalogs and downloading the models which are available to that catalog. Again, the key thing around running any of the Foundry models is memory capacity. So you will need like GPU, NPU, or CPU capacity to support those models. So, typically in Foundry Local, these are small language models. You're not running GPT 5.2 as a model available. So, these are typically ranging between like half a gig. So like when 0.25 is 500 megs, all the way up to GPC OSS, which is about 12 gigs. So again, if you're running a CUDA box, you need at least 12 gig of memory to run like the majority models. But what is very nice is that when you run Foundry Local actually spawns a localized port. So the endpoint is a localized port on your machine. And each time you load a new model, you can have a new endpoint. So you can have multi-model inferencing on the same device, 2 different models. Of course, you have to have the GPU memory available, or CPU or NPU model memory available, but you can have multiple Foundry Local instances serving different models. So again, that's really interesting when you start to build multi-agent implementations using something like Microsoft Agent Framework. You can then say like, agent 1 goes and speaks to GPT, agent 2 goes and speaks to Quen, agent 3 speaks to Phi. So again, that's quite an interesting opportunity, isn't it, Sam?
Yeah, that's right. Like in those multi-agent scenarios where you might want to use different models for different things, it's you can have that those kind of like loaded in and let the OS handle like the paging in and out of those models.
Cool. So do you have any more details for us around Foundry?
No, I guess like just to sort of give a bit of a steer on what we're working at, what you can expect from the next couple of months. As you mentioned, like we're in preview, so we're working towards GA. So that should happen in the next few months, and then also, as I mentioned, like audio's become a big big sort of new workload that we're adding in. So what we had at Ignite was the ability to do like the recorded scenario. So you could give it a file or like push button scenario. So you might push button, speak in, stop the button, and then it will transcribe that for you. We're kind of working more on kind of like real time live captioning and stuff like that, all happening on the device. So those are some of the things to kind of look out for in the next few months.
And again, that's due to like the availability of new models. So I know the push button, I've got a demo in my repo around using the Whisper sample. I've actually done that in a .NET. So, you can actually just use like Whisper to do audio transcription. So, you upload a WAV file or an MP3 file, it will then transcribe the file, produce the output. So I think the scenario I have is a medical example where it's doctor's notes and it transcribes the doctor's notes. And again, that's all done on a local private basis. But then we move into newer models like GPT real time and Vibe voice, which are going to offer a lot more opportunity out there, Sam, in terms of what developers can do with these new multimodal audio models. Yeah,
that's right. So there's a lot of work happening there. Also, like Nemotron as well, and like Moonshine AI. There's a lot of work happening there in terms of audio, and the efficacy of those models is going up. So like in Whisper, which is very much geared towards like the recorded scenario, because it's kind of trained on 30-second segments, and it doesn't behave particularly well when you go to like live captioning, where you're talking into a microphone. Whisper will do well in the sort of batch mode. You give it a file or push button stream, it'll probably get like a word error rate of around sort of like 5 to 8%, depending on which size of model you use. Like when you start to use that in like real time, and like the word error rate that goes down substantially, it's more like at sort of 15%. Some of these newer models that are coming out that are designed for the streaming input and output, they're sort of getting word error rates of around sort of like the 6% mark again. So and they have a very small footprint, these models. So I think that's something to kind of keep an eye on, just in general, like as you look at these models that are coming out.
Yeah, definitely. Excellent. Okay, so if we switch over to demos, and if you want to share my screen, thanks, Anna. We can sort of go into a few of the demos around Foundry Local. So first of all, I just want to take you through the CLI. So in terms of the CLI, this is all CLI based. So we basically, Foundry is the name of the application. So we can do Foundry model lists, for example. And as we talked about earlier on, this basically lists all the models which my current device supports. So you can see at the top, we talked about, how Foundry Local is running. So we're running on a local port on the local host. So we're currently running on 4162. So one of the key things about Microsoft Foundry Local is that port is dynamic. So again, when you're actually looking at developing code, you're looking at, how do we call the dynamic endpoint? Again, it supports OpenAI. So you've got an OpenAI endpoint as well. Again, we look at this EP, so the execution provider. So when we run the Foundry model list, it's looking at this auto registration to ensure we successfully download all the models which your current hardware supports. So you can see, the registration says that I can support CUDA. It's not got anything for OpenVINO because this isn't running an MPU on this device. It's not running anything for NV Tensor RTXs because it's not AMD. So it's provided the models which this device has. So this device I currently have, I'm using at the moment, it's got GPU and CPU. And you can see I've got the variants of the models. So, 5, 4, 5, 3, etc. Lots of models. I think there's more than 30, Sam. There's a big list of models. We then have the size of the models. So what I was talking about earlier is when we said the size, that's how much memory this model is going to take up once it's fully installed. So again, you should be thinking about how much GPU does your device have? Can it support that model in full operation? Can you run multiple models? And again, then you've got licensing type. So these models are exactly the same as the models that are available in Foundry. So they're Microsoft certified, they're Microsoft safety secured. They've gone through that optimization to create the different variants based on the hardware, and then they're presented to the machine. If I wanted to run a model, I can just do Foundry service, Foundry model start or Foundry model run, and then the model alias. So I just simply use the alias to start that model. I already have some models running, so I can just do Foundry service status, and it will show that I currently have things running. You can see I'm currently running and on the same port, which is great. I can also do Foundry cache list. So when you install a model, the model is downloaded and it's actually stored within a secure container within your folder structure. So within Windows, it's under the user folder. There's a .foundry folder. Inside the .foundry folder, there's the model caches, and this is where the models are listed. So I can see on this device which models I have as hot models. So, I can simply change the model alias to one of these aliases, and the model will automatically be there ready to be used. It's not like I've got to wait for it to be downloaded or wait for it to spin up. The spin up time's like very, very fast because it's a hot model as such. So this is one of the really nice features, especially if you've got machines with lots of GPU capacity, or you can run lots of models, that you can have lots of hot models. And again, multi-agent, great example of where you can switch between these models. As I said, these models range from really small to like Quencoder, 500 meg model. This model I think is phenomenal. I love it for just doing like specific coding tasks. It's amazing in terms of its performance, and it's very, very small, to GPT OSS, which is like 12 gigs. So again, a huge variety of models. So what I want to do now is sort of go into a couple of demos and talk to you like, how do we build these solutions and what types of solutions can we build using Foundry Local? Now, this is, it's an SLM engine, so there's no restrictions to what you can build from a technology perspective. It's more around, the size and capacity of your machine. So if I go into a demo first of all, this is one of the examples that I've built, and this is using a Blender model to reconstruct a building environment. So this is like a virtual support desk for HVAC, so for high voltage air conditioning and support of a building. So you can imagine this is being used by staff within this office space to manage the office space, so they understand what the rooms are in the building, what the temperatures are in the building, how many people do they have. I've got a 3D digital twin of my building. And again, this is all using Foundry Local. So you can see it's connected to Foundry Local. I've got my different buildings, so I can switch through and see the different areas of the building and understand like what the current temperatures are, what the current environmental sensors are picking up. I've got different controls, so I can change the response levels, and I can run a simulation, which will change the building's temperature, etc. I can see where the plant room is. So if I look on where the mechanical room is, it's on the ground floor, and I've got assets within that, so I can see the physical plant itself. I've also got things like KPIs. So again, this is using the models within Foundry Local to bring back this information in real time and to be able to give that interaction alerts and system status. So again, I've got a co-pilot, so I can interact with the model. So this is running the file model behind it, so I can say like, what's the building status? And it comes back instantly with that details, very, very low latency, because this is running on device. I can ask a question about, what's the current temperature in a room? So I can just do free form. And it's come back and said like the current temperature in the lobby is 1.1 below the set point. It's currently 100% on target in terms of comfort. So again, you've got huge interactions by building these localized models. So again, think about this from like a secure building perspective. This is running on-premise, on-device, talking to the HVAC systems, providing that information directly to the end users. So if we look at the code behind this, It's very simplistic, really, in terms of what it is. So this is the digital twin example, and I will share these repos with you so you can actually look at it. So all our LLM controls are within the Copilot service in the JavaScript function. So you can see, this is documented in terms of what we're actually going to do. So it provides intelligent assistance, it's natural language, has execution opportunities, so you can do set point simulations. It's grounded in responses from the digital twin, so it's looking at the model and updating the model. Again, we've got a set of intent patterns. Again, in terms of the model usage, so if I go down to, I think it's 361, line 361. Here we go. We should have the model set point. Let me find it. I'm trying to find, there it is. So there it is. So it's 631. Sorry, my fault for the line number. So you can see that the model we're using is the Phi 3.5 mini, and we're also giving it a max tokens and a temperature as well. So we want this to be like 0.7 in terms of temperature. So not giving out verbose answers. And again, we're giving it a set of limited tokens to utilize. So again, we want this to be as effective as possible. So again, it's a very, very simplistic implementation. Uses Blender to build that 3D model and assets. And again, this is all based on the Foundry SDK, using the JavaScript APIs and the JavaScript SDK to construct this. And again, it's a really nice demo in terms of the operation of how this utilizes, a localized model to give a very fast response. So again, you can see where we've got the construct to our Foundry local endpoint. So we just call them the local endpoint and the port number. And then we've got a port number for the actual website. So in terms of the way this is built, we've got a back-end infrastructure, which is doing our WebSockets. It's building also the simulation data, so we can simulate each of those different services. And then we have a website, which then is available as a local hosted website to deliver the UI and UX, where we can interact and zoom in, zoom out, and have these interactions with the simulation. Another demo I wanted to talk about was using JavaScript in terms of game development. So one of the simple things is building website games. So I'm sure everybody sort of built a website game quite quickly. And this is a simple Space Invaders game. But what we've done is we've added in LLM integration into the game. And again, we're using the Phi model. And what we're doing with the LLM integrations is adding some verbose, like taunting and character talk responses. So we have fallback responses for taunts and briefings, or we also have the live responses from the LLM. So again, when we start to play this game, the LLM understands how we're playing the game, it understands our score, it understands the position, and again, it starts to add these overlays into the game, again, using JavaScript and using the SDK to actually have that level of interaction. So if I go over to the game itself, and we can start the game. So again, it's just a Space Invaders game, and you can see the taunts coming in at the bottom into the chat window. And it's like, you can't stop us, etc. Showing how bad my Space Invader skills are. So again, that's a really interesting game where we've built using LLM just to add that extra bit of nuance to the gameplay. And again, you can build this into like an RPG game, a text-based game. Just, it's pretty much unlimited what you can actually achieve with these LLM integrations. And again, what Sam was talking about before, because this is using Foundry Local, I can just simply share this deployment, and it can be installed on a Mac, it can be installed on Windows. It will just work. It will just understand we're using Foundry Local. It needs to load Foundry Local from the npm install. It knows what port number we're going to be dynamically assigning to. It knows which model we need to download and utilize. So again, very, very effective in terms of the implementation, and very simplistic. This is simply just a web-based game. It's got a standard static HTML file. We have our LLM in a JavaScript. We have our server engine. Very, very simplistic. This is something like, pretty much can be vibe coded in 25 minutes. So again, really, really neat solution in terms of getting started. One of the other things I want to show is what we were talking about in terms of the use of Microsoft Olive and Olive recipes. So this is the Olive recipe site, which we talked about in terms of being able to take models, because each model has a different architecture. We want to basically make it easy for you to actually take these models, build these models, and distill these models in the variants you wish. So under Olive recipes, we have pretty much most models. As you can see, we've got the Quen models, we've got the Phi models, we've got DeepSeek models, we've got the Meta models. Each of these is simply just a notebook on how to distill the actual model to an optimized format. So again, this is a great resource to look at. I did share this resource as well, which I think is very good. It's a Microsoft Foundry samples for one of my global belt teams. And it's based of 6 notebooks. So we've got to getting started with what Microsoft Foundry Local is, which talks about like the implementation, how you run it. This again is all in Python and it's based in notebooks, but it's a great walkthrough of how to get started with Foundry Local. And this is what we were explaining before about the developer experience. So we have our AI Azure Foundry models, which then go into the model management, and then we have our services. So everything is running on the Onyx runtime. And as you saw from my, when I went to the command shell before and showed you the model caches, we have the models which we previously downloaded, which then become available directly to the developer experience. So again, it's a really nice notebook. But in notebook 6, it has a great example of using the Microsoft Olive toolkit to optimize a model. So again, if you go through this, it's literally the optimizing steps to optimize and build a model for your specific hardware type. And again, what's really interesting about Olive, and Sam, jump in on this part, but when you run Microsoft Olive, it will produce each variant of the model in a single build. So when I run this notebook for Quen 2.5 Instruct, the outputs that I will get at the very end will be an optimized model for QNN, for Intel Vino, for GPU and CPU. So again, it's really nice in terms of having that functionality of just being able to run optimization once, then have all the available downloaded packages in a single folder. And you can just simply then bundle that and say, okay, there's all my models that are required for this specific model. So again, really, really neat solution. So please do have a look at that. Sam, is there anything else I think I need to show? I've got a couple of minutes left.
Oh, so I think that covers it. Do we want to answer some of the questions that are
Yeah, let's answer some of the questions. So if we can share or unshare my screen and I can see what questions we've got. Great. So let's just go back and see what we've got in terms of question-wise. Lots of people asking questions, which is great. And we do have an AMA after this in Discord. The cat has more AI knowledge than me. It's just sitting there. She is being a pain. She's ripped up my carpet trying to get out. In an enterprise environment, would a special firewall type rule also be necessary, or does it require data governance compliance? That's a great question.
So
Sam,
it kind of depends. If you're running this where it's got like the REST server running, then you would need to open up the firewall potentially for that port. But like we described, like that's optional, right? You don't need to do that. You can go fully native, and there's no kind of going over the network or anything like that.
Yeah. So again, everything is running fully native. So think about this: it's literally running local host. So again, if you're running a containerized environment on a GPU resource in your environment, that would be running, you'd have to put like port forwarding, etc., to the clients that want access to that resource. But again, you compartmentalize that within your localized environment. In terms of the Buildathon, there's a question from Silvestri saying, in terms of the Buildathon, this is focused on JavaScript. So we're specifically looking at JavaScript and the JavaScript SDK. You know, if you do want to run model optimization, you have to run that in Python to build your models, but then build your application in JavaScript. We're on this, yeah, so we're on Discord. We do have a dedicated Foundry Local channel also on Discord. So if you do have specific questions around Foundry Local, it's just hash Foundry-local. So if you do want to ask questions there. So another question is from C Boda. Is there still an Azure VM machine available with high GPU that can be pre-installed for something similar? Yes, you can. So you can install what Sam mentioned earlier on, an A100. So an A100 is an NVIDIA GPU virtual machine that can be installed in Azure VMs. So within virtual machines, you can then SSH into it if you want a Linux version, or RDP into it if you want Windows. Install Foundry Local and make it available. There's a number of blogs. If you look at the Foundry Local Discord channel, we've got blogs on how to set it for Windows Server 2025. Windows 11, you just need to have winget support.
Yeah, I think also there's quite a lot of like A10s as well, which they also come with quite a lot of hype, particularly for the LLMs that we have in Foundry Local. For like the price point and everything, they're very good as well, very effective.
So Marcus Hightower's got a question saying, am I missing the point, or is this just Microsoft's version of Ollama?
Yeah, so I'd say like you know, there's some aspects where it's similar. I think that's you know, fair, like where we have like a kind of CLI that you can kind of run models. That's mainly for sort of like testing and exploratory purposes. I'd say like the kind of difference with what we're doing with Foundry Local is making sure that everything can run self-contained with your application, like all the dependencies are there. So with Ollama, there's an SDK, but it's dependent on you installing Ollama, which is very hard. Like if you want to ship your application, that's pretty hard to manage. But yeah.
Yes. Cool. Seabold has asked a question like, on the HVAC model simulation, what's the business purpose? So the whole business purpose is digital twins. So imagine like an architect wanting to plan a building and understand the HVAC capacities. So it's got two purposes. It's got like a pre-build environmental simulation or a post-build maintenance operation. So, you know, if we increased our building capacity by 30%, what impact does this have to our building? So again, if you have a play with it, there's lots of simulations there that show you the impact of running various different business models against the business KPIs. And again, what impact that has to the building. So digital twins are like a massive opportunity now. Organizations like NVIDIA have built tools like NVIDIA Omniverse, which are basically the ability to build digital twin models. You connect that with Foundry Local plus LLMs. It gives you that intelligence over the top of the model. So again, that co-pilot in terms of really digging deep into the business intelligence of the outcomes of that simulation. So I hope that helps. So time Peachtree, I mean, this can be helpful for text to SQL without sending schemas to external providers. Not sure what he means there.
I think if you've got your, the usefulness is in SQL, you don't want to expose your schema, right, to an external like OpenAI or Anthropic, for example. You don't want them to see that, but having it local where you can expose the metadata that would to generate the SQL is useful. I think that's what they mean.
Okay, I'm going to do one more question. I'm going to hand back to Julie because we're nearly at time. So somebody's asked, should we do fine tuning or RAG? So think of this always as a funnel. Okay, prompt engineering at the very top, very cheap, very effective to do. RAG, you're adding data to the model. It's going to be a bit more costly because you've got data being added, data needs to be stored. Most importantly, data quality. Are you 100% confident in the data you're adding? Fine-tuning, last choice. Very expensive. Still a data science thing to do, really, to understand the concepts of fine-tuning. And most importantly, It's run once, so you run it today. Your model is only fine-tuned on today's data. So fine-tuning is like your last resort, really, honestly. So that's my comment on fine-tuning versus RAG. Julia, thank you. I know we're at time.
No worries. That was lovely. I enjoyed the session. And judging from the interactions on the chat, I can tell that this was incredibly helpful. So thank you so much, Lee. Thank you so much, Sam, for that amazing run through of Foundry Local. I know you have so many questions that we've probably not yet addressed. So immediately after this stream, we do have a dedicated AMA session on Discord. And I'm just going to be sharing my screen briefly with the link so that we can just all transition to Discord for that AMA session. So I think I'm just going to quickly walk through the Buildathon program. So I mentioned what it is and how to get started, but I forgot to just show the repo and basically what your experience will be for the next couple of days. So I'm just going to quickly do that before we wrap up. Now, this is the repository. This is the main repository where you'll find all the resources and all the quests that we have prepared for you. We also have a site. So basically, this is how you can navigate the different components of the Buildathon that we have. As I mentioned, we do have live streams, we do have hands-on quests, we have guided projects. So through this website, you'll be able to basically see all the resources that you can use to deep dive into what we've covered today, as well as the upcoming live streams. So here's the schedule of what to expect. As I said, we'll have the live streams running this week and next week, and then we'll have a hackathon. We will launch details about the hackathon on 13th of March when we go live with our hackathon page. So definitely stay tuned for that. This link will prompt you to register for the entire series. So we have a bunch of live streams lined up, each covering a core concept that you will basically need to participate in the hackathon. So this is where you can register for the entire series. And then all that I've shared is basically what we are summarizing on this one page, as well as the direct links to all the live streams and all the Discord AMA sessions. Then once you are done with that, you can join in our Discord space. As I mentioned, we have the hackathons and events page section. And then under there, we have the JS AI Buildathon channel. So this is where we'll basically be spending most of the time interacting with you, and you can find community builders who are interested in collaborating with you on projects. So with that, you can hop back to my slides. And we are just going to transition to the next session, which will be a 30-minute AMA. We'll get to connect with both Lee and Sam and answer some of the questions that we are yet to address. And if anything needs to be clarified further, we're also going to do that in the next 5 minutes. So this kicks off in 2 minutes. So you can scan the QR code on the screen to join the Discord event, or a link will also be dropped on the chat, which you can use to access the same platform. So with that, we will wrap up. Welcome all to the Buildathon. I hope that you'll have an amazing time exploring different technologies and building AI using JavaScript. So I'll see you in 2 minutes on the AMA to interact more with Lee and Sam.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.